So we are doing section 5.2, and this is properties of functions, and we're going to continue it from yesterday. So we can write an equation that represents a function using function notation. For example, to show that c equals 15 plus 2n represents a function, we write c as a function of n equals 15 plus 2n. This notation shows that c is the dependent variable and that c depends on n. We say c of n is equal to 15 plus 2n. And you can go through example 3 if you need to. I'm going to show you one more example. So we're looking at functions now, and this is kind of a tricky way to write relations. So Frank sells memberships to a local gym. The equation E equals 50n plus 150 represents his weekly earnings. E is the dollars and n is the memberships. So we want to describe the function by writing the equation using function notation. So, E, which is the dollars he makes, or Frank's earnings, are a function of the number of memberships that get sold. One depends on the other. So in function notation, E is a function of n, where 50n plus 150 becomes the earnings. So find the value of E when n is equal to 9. So this number that we're going to find is going to represent his earnings when he sells 9 memberships. So we substitute 9 for n. 50 times 9 is 450, plus 150 is equal to 600. So this means that when Frank sells 9 memberships, he earns $600. Well, now they want us to go backwards. Find the value of n when E of n is equal to 850. So this number represents how many memberships he's going to have sold when he makes $850. So I'm going to put that in here, and now I need to go the other way. I need to solve for n. To do this, I'm going to subtract 150 from both sides. Leaving me with 50n is equal to 600. And then I need to divide both sides by 50. And this is going to give me 12 equals n. So n equals 12. So if Frank sells 12 memberships, he makes $850. Or when the earnings as a function of x equal 850, that means the number of memberships is 12. Frank sells 12 memberships, he earns $850. So now we've learned everything about section 5.2, domain, range, functions, and we can finish the assignment from yesterday, where we did 1, 2, and 3. Now, I just wanted to clarify, many students have no idea what a function is. And so here, let's look at the assignment from yesterday where speed affects the find. So this is our dependent variable or our domain, or our independent variable or our domain, and this is our dependent variable and our range. So what I like to think of as a function is as a machine. and we think of it as a function machine. So in order for it to be a function, it needs to have a unique domain. So when I put a speed in, or S, I get a unique find, or F. If I put two different speeds in and I get the same, like two of the same speeds in, and I get finds for the same speeds that are different, that's an issue. So that's why for a function, we need a unique input, and that will give us different outputs. The outputs can repeat, but a function is basically like a machine where we put something in that's unique and we get out different outputs. Now today, I would like you to do all of 4, all of 5, all of 6, and all of 7. Good luck. Let me know if you need help.